The collection of economic rents is very important, but in order to do that, we need to have some solid theory behind it. We're going to do this by looking at rent collection in forestry. Governments own forest lands and wish to benefit from their exploitation by private timber companies, sometimes known as concessionaires. In tropical regions, government may own all of the forest land. In Canada, provinces own as much as 95% of forest land, as is the case in British Columbia. The United States has national forests that they are exploited by private companies, so the timber is sold by auction to these companies. The question is, how might governments go about collecting the resource rents from the forest lands they own? I've already mentioned auctions as one possibility, and we'll see that in a little bit more detail. So there are two types of forest rents. We classify them according to whether they're at the extensive margin or whether they're at the intensive margin. The extensive margin occurs because of location. It's the boundary between the working forest and nature. So, for example, in Sweden, the working forest is about 95% of the entire forest, whereas in Canada, in British Columbia, it's less than 60%. On-site or extensive margin occurs where, and as a result of, not all logs being removed from a site. Timber companies will remove logs only if they will earn at least as much as the cost of removing the log from the site. So here we have first off the extensive margin, the location issue. So what we do is we order stands according to their declining value in terms of what rent could be made from them. So we are assuming that the variable costs and even the fixed costs of the companies are taken into account, and that the resource rent is that difference between the price and the marginal cost on the all human factors of production variable supply curve. So we see that some stands of forest are located very near to sawmills. Some are located very high up in the mountains. Others are located very far from sawmills, such as would be the case in much of the boreal forest of Canada. And what we do is we order these stands in declining value. And as the stands are less and less valuable, you'll notice that this rent function falls until at point N, it's essentially zero. So N, 0N represents the number of stands, and the line AB represents the rent function. Now at point K, the resource rent is effectively zero, which means that if you're going to harvest any stands beyond K, you're going to lose money. Not only does the government, the owner, lose money, but the harvesting companies, the timber companies, lose money. So the working forest, therefore, is from 0 to K, and it's the amount of stands that can actually earn a positive rent. At the intensive margin, we arrange logs in decreasing size and value. The demand for logs is given by the value marginal product. All right, VMP is simply the marginal willingness to pay of companies, of timber companies or concessionaires, to purchase logs or to harvest logs from stands. Now, the VMP is simply the price of a log times the marginal product of that log. Therefore, it represents the demand function. We assume here a marginal cost function that is horizontal, so it's fixed throughout. It's done for convenience. We could have an upward sloping one just as well. And it's where the marginal cost and the value of the marginal product, in other words, the supply function and the demand function, intersect at point M. So any logs greater than a diameter, say, of M, are going to be harvested. Smaller logs will be left on site, and smaller trees may or may not be cut down, but they're certainly not taken to the mill. Now, government can levy a stumpage fee, which shifts the value of the marginal product down. Think of it as receiving a price for a log, and the government now charges a fee for that log in order to capture the rent. Well, what it does is it increases the size of logs that companies are willing to harvest, which leads to what we call high grading. Now, the government can turn around and force companies to harvest small logs by using a utilization standard, but this will dissipate rent. This will reduce the rent available to both the government and the companies. So how do we collect forest rents? Well, there are 4 methods that can be used to collect forest rents. First is a fully differentiated royalty or tax. Second is a uniform fixed royalty or a uniform specific royalty or tax. Then there's an ad valorem royalty on revenue or price. And the 4th possibility is an ad valorem royalty on the difference between the price and the marginal cost for each log. Now, you can think of the informational requirements for a fully differentiated royalty versus a royalty which tries to figure out the difference between the price and the marginal cost compared to one that's based only on the price. So let's look at these. For a fully differentiated royalty, each individual log royalty, so for each individual log, the royalty or tax varies by tree species, size of log, location and quality of land, harvest costs, delivery costs, etc. The thing is, all resource rent would be collected, but informational requirements are great. In fact, they're impossible, and forest ministries in both developing and developing countries are unable to implement it. So with the fully differentiated royalty, the attempt would be to collect all of this available rent from point E to A to B. So this kind of triangular area would be the total rent. Remember, marginal revenue here is our demand, marginal cost is our supply. So we have a producer surplus and a consumer surplus. But remember now that this marginal cost is your all human factors variable supply function. So this area here, which we would call quasi-rent, is actually now differential rent. The second type of method for calculating or for determining the amount of rent to collect is a fixed uniform royalty. So we charge the same amount on every cubic meter of timber removed by the concessionaire from the forest. With no fees, the timber companies would seek to maximize their profit, which is given by the price of trees, but the price of trees is going to be, or the price of logs is going to change by the harvest amount, H. So it's price times H minus, so price times the amount harvested minus the cost of harvesting, which also will vary by the amount of harvest. The solution in this case, using the product rule, we first get the first derivative of this function with respect to H. Using the product rule, we get the first derivative of price with respect to H, with respect to harvest, times the harvest amount, plus the first derivative of this expression with respect to H using the product rule. We get the price of H coming out, and on the right hand side then, once we've shifted that, we get the marginal cost. So the marginal revenue is equal to marginal cost. With the fixed royalty, the marginal cost is increased to marginal cost plus the amount of the royalty, RU. So then the profit function becomes price times harvest minus the cost as a function of harvest minus the royalty times the amount of harvest. And if you do this same thing where you set the first derivative of pi with respect to H equal to 0, solving, you get marginal revenue equals marginal cost plus the royalty rate. So we increase the marginal cost. This distorts harvest levels, and it leads to high grading, which is the practice of selecting only the best logs or trees for harvesting, leaving smaller, less valuable trees standing or damaged or lying on the ground. So we can picture this as a shift in the marginal cost curve from MC to MC plus RU. So the supply curve shifts up, marginal revenue curve stays the same. Now the amount of logs harvested is going to decline from H1 to H0. What happens is that the amount of the royalty, RU, is equal to DA, which is equal to CF. The harvest has fallen. The government collects DAFC, this area in between the two supply curves. It collects that as a rent, leaving EDC to the concessionaires. So the rent loss due to high grading is given by this triangle CFB. So let's look at the ad valorem royalty as a proportion of price. We'll call that R sub A. So we set this as a proportion of the selling price. So the profit function is now 1 minus R of A times PH times H minus the cost of harvest as a function of harvest. And we solve it the same way using a product rule of calculus. And we find that the marginal revenue equals to the marginal cost divided by 1 minus RA. So high grading still occurs, and let's assume that RA is set in such a way that we achieve the same amount of harvest as we did with the uniform royalty. So we see that here. We have a decline from H1. Here's the old marginal cost plus uniform royalty, and now we have the marginal cost divided by 1 minus R of A, where this is a much steeper supply function, but we have adjusted RA so that it goes through the same point C as this case here. So now the government collects AFC, all right, so it collects this area here instead of this former area DAFC under the uniform royalty. So the amount of rent that's collected is smaller. So that means that the concessionaire's windfall is larger, EAC, and the rent lost to high grading remains CFB. The final is an ad valorem royalty as a proportion of profit. So we set the proportion of difference between the price and the marginal cost. So in this case, we have profit is equal to 1 minus R, P all times P of H, H minus C of H. So the difference between the revenue and the cost. And when we solve that, surprisingly, we get that the marginal revenue equals the marginal cost. So there's no high grading. All right, so what does this look like? Well, in this case, the royalty as a proportion of profit results in this supply curve here. All right, so again, there is no shift in the amount that's harvested. So in this case, the government collects DAB, so again, a smaller amount than under the uniform royalty. Well, we don't actually know, it depends on this area versus this area here. The concessionaire's windfall is EDB, right? So this area here. All right, so then what we can do is look at all three of these as the methods of collecting the rent. And the rent collected is going to vary from DAFC under the uniform royalty to AFC under the ad valorem royalty on price to DAB be under the ad valorem royalty on the difference between the price and the marginal cost. So how can we get to this in theory? Competitive bidding can be used to collect all of the rent. As I mentioned, it's used in the United States, and now it's used in parts of Canada as well. However, there are problems. There's the problem of ex ante versus ex post rent collection. Ex post expectations may not be met, and logging companies could renege on payments, or no harvest at all occurs. Large firms may bid on the basis of sliding down a long average cost curve so that their costs are much lower than that for the smaller firms, and thereby they are able to outbid small firms. And another problem is that in some areas like northern British Columbia, the distance to mills is great, and there are very few mills in some areas, and as a result there are a small number of bidders, so we have a thin market. So finally, the governments in Canada often institute policies that fail to collect resource rents or collect quasi-rents. In other words, they collect that producer surplus, and that leads to a reduced investment. Part of the problem is that the objectives of government and forest policy are not always interested solely in rent collection. Governments are interested in employment and regional economic development. They're concerned, yes, with revenue. In other words, they are concerned about resource rents. They're also concerned about exports, and there's a big debate about whether Canada should allow exports of logs rather than having them process the logs at home, which is sometimes more expensive. Sometimes it's cheaper to export the logs and import the lumber or other products made with those logs rather than doing it at home. And there's the whole issue of protection of ecosystems, and that's a response to environmental activism. Complex systems of tenure rights have evolved in Canada to capture revenues and achieve other objectives as well. But these are very complicated, and colleagues of mine in forest resources management at UBC have spent a career looking at simply tenure structure.